Good evening to everyone. Today we will discuss on the topic standard deviation. So previous classes we have discussed about that what are the absolute and the relative dispersions of the measures of dispersion. So standard deviation is one of the absolute dispersion, the measures of dispersion. So here, what is mean by standard deviation? When we have that mean deviation and quartile deviation is there. So what is the use of standard deviation? So we can come to know that what is the standard deviation and how we can apply, how we can do, how we can calculate the standard deviation for the individual series data and continuous series data. So here the introduction of the standard deviation. So here it is the most important and most used measure of dispersion. For example, see when in the statistical, when you are using the statistical property, when you are using statistical tools. So when you observe in the most of the research, so most of the times, so the standard deviation will be used. Nothing but here, so which is a main important the standard deviation and which can use more times in the research orientation. It is an improvement over the mean deviation. For example, so you have somebody may have the doubt that there is a mean deviation. What is use of standard deviation? For example, see, so when you compare the mean deviation and standard deviation, the standard deviation tool is a very important tool which can give the accurate results compared with the mean deviation. So that is the case. It is an improvement over the mean deviation. And the standard deviation was introduced by the Carl Pearson in 1893. So the standard deviation, which was introduced by the Carl Pearson in 1893. The standard deviation is the square root of variance. Simple. Sometimes they will ask that what is the standard deviation? Standard deviation is the square root of variance. Square root of variance. So we didn't go for that variance. Then after completion of the standard deviation, we can go for the variance. Then you can come to know that what is the square root of variance. For example, there is a variance formula is there. So when you square root, you will get the standard deviation. That is called the standard deviation is equal to square root of variance. Square root of variance. And the standard deviation gives positive square root of variance, not negative square root of variance. You can remember this. This is a very important point. The standard deviation gives a positive square root of variance. It cannot give the negative square root of variance. The standard deviation is the square root of average of squared deviation. Average of squared deviation. For example, see whatever we get the some deviation that is called x minus x power. So within that we need to square it. That is called after square that deviation. So we will get some average square of deviation. That is called standard deviation. So the standard deviation is the square root of average of squared deviation. Whatever we get that deviation, that should be squared it, and it should be in the under root. That is a standard deviation. That is called the standard deviation is the square root of variance. Variance is nothing but whatever we have the values, that is average of square deviation, x minus x power, something for summation of x minus x bar whole square by n number of observations, or sometimes we can put n minus 1 also. So where in which cases we can use n minus 1 and in which cases we can use n. So we can come to know the next slide. Standard deviation denoted by sigma, but sample standard deviation denoted by the s. So what is why the standard deviation is denoted by sigma? Generally, the standard deviation denoted by sigma, but when we have that large number of variables, we can use standard deviation, that is sigma. But when we are using the sample, when you are going to calculate the sample standard deviation, we are going to use s symbol, small s. Okay. So generally, most of the time we can use sigma only. Okay, but with particularly when we are going to estimate sample standard deviation, we can use s, small s. Nothing but the sample standard deviation is denoted by small s letter. Okay, is it clear about the standard deviation? Then there are formulas for ungrouped data. For example, see the formula for ungrouped data. For example, as we know that there is a grouped data and ungrouped data. So previous class we know that what is grouped data and what is ungrouped data. Similarly, in this case of standard deviation also, we can use the formula for the different formula to the ungrouped data and another formula for grouped data. See, for example, say the formula for ungrouped data. For example, when you estimate the samples, what is it called, samples standard deviation, you can use S is equal to under root of summation of x minus x bar whole square by n minus 1. N minus 1. So as we know that summation is nothing but total value of x minus x bar. Here x value minus average of x square divided by n minus 1. So here see, when we can use n minus 1, when we have the small sample, we can say the simple, when we have the small sample, we can, what is mean by small sample? So in research we can say that small sample is nothing but when the sample size is less than or equal to 30, less than or equal to 30. Simple. Small sample nothing but when we are collecting the sample which are less than or equal to 30, that is called small sample. When we are going to take the large sample, nothing but more than 30, more than 30 number of samples, that is called large number. Okay, so in case of large number, we can see the formula for large number sample, large sample more than 30, that is standard deviation is equal to summation of x minus x bar whole square divided by n only. There is a small difference between small sample and large sample. So sometimes we cannot put n minus 1, sometimes we can put n. Okay. So that is called population. Generally, we can call population when you're using the standard deviation formula for the estimation of population standard deviation. Population standard deviation. Population standard deviation. See, for example, in order to calculate the population, that is called population sample, population standard deviation, we can use sigma. This is sigma, not 0. So it is unable to write properly. Here, sigma, like this. Okay. Sigma is equal under root of summation x minus mu whole square divided by n. So here sigma is nothing but standard deviation is equal under root summation is nothing but total value of x minus mu. What is mu here? So here mu is nothing but population mean. Population mean. Here x bar is nothing but sample mean or sample average. Here population average. So don't bother about. So in when you are writing the formula, that is called mu. This is called a simple average. X minus, we can put out x bar also, no problem. But we can write capital X. It doesn't matter. But if you write mu, that is a this formula is followed. Nothing but population standard deviation formula, like that. So don't bother about x minus x bar. You can write it, and x minus mu is nothing but it's a population mean. Population mean, nothing but average of the population data. Average of the population data. So here population is nothing but as per in statistics, population nothing but total information. Please keep in mind. Okay. So those who did not attend the previous classes, the population is not a how many members are living in particular area. That is not a population in our research or in our topic. Population is nothing but total information of the particular variable. Okay. So here when you compare the population and sample, there is a small difference that is called mu and n minus 1 and n. Please keep in mind. Okay. So we come to know that what is the formula for ungrouped data and what is the formula for large sample, and so we can come to know that formula for standard deviation for grouped data. For example, what is grouped data? For example, if they will use data in the discrete mode and continuous series, so we need to follow other formula, that is sigma is equal under root of summation f into x minus x bar whole square divided by summation of f. So simple, we added here f, that is called frequency. That is called frequency. So after calculating the x minus x bar, and we can do x minus x bar whole square, then after that f into x minus x bar whole square. Then just we can multiply it, the frequency into x minus x bar whole square. Okay. So here sum of f is nothing but sum of frequencies, nothing but total number of observations. Is this clear for that formulas of standard deviation? Hello, dear students. Oshasri and Somnath and
yes, sir, it's clear.
Yes, sir.
Yeah, thank you. Then see, we can go into that calculation part. For example, you can write in notes, find out the standard deviation of 2576. So sometime they will ask that find out the standard deviation of 2, 5, 7, 6. So they are given the 4 values. We need to find out the standard deviation. Standard deviation. So this is called X. For example, if you take marks or if you take into account your earning nothing but your income 2000, 5000, 7,000, 6,000 like that also you can imagine. But X is equal to 576. For example, if you take it upon is a income, so the values in thousands. Okay. For example, if you take into account your marks, you will take in the numbers 2576. Okay. It doesn't matter, but you need to understand how we can find out the standard deviation. So first we need to understand this question. So the standard deviation of 2576, which is a small sample or population or the large sample. Only there are 4 observation. Is it small sample or big sample? Hello, dear students. Somnath, I'm Prasad and Usha. There are
It's small sample, sir.
only because I have collected only from the 4 students. For example, their internal mass
Yes,
is
sir.
2, 5, 7, 6. Very good. See, small sample. Then we need to follow this formula. S is equal under root of summation x minus x bar whole square divided by n minus 1. This is the formula. You can remember. So in that, x is nothing but the marks. X is equal to 2, 5, 7, 6. Like this, we can enter it. Then after that, what we have to do? X minus x bar. What is x bar here? Average of the x values. How we can get the average value? Sum of x variable divided by number of observations. So here mean value is equal. Sum of total value is how much? Sum of value of x 2, 7, 7, 2 plus 5, 7, 7 plus 7, 14, 14 plus 6, 20. Then 20 by n, nothing but number of observations is how many? 20 by 4. You can get 5. Okay, 5. So then after that, after getting that x bar value is 5. Then what we have to do? X minus x bar. You can find out next step is x minus x bar. Then here x minus here x bar. Then what is x here? 2. What is x bar here? 5. The average value. Okay. Then 2 minus 5 minus 3. 5 minus 5 0. 7 minus 5 2. 6 minus 5 1. So each and every time we need to write x bar is equal to 5 only. Then x value is nothing but 2, 5, 7, 6. Okay. So when you do minus, nothing but when you subtract from this 2 to 2 from 5 to 2, you will get minus 3. Okay. Then after calculating that x minus x bar, what you have to do? You need to square it. You need to square it. Square the deviation. Nothing but square the deviation. We got the deviation x minus x bar. That is called deviation. Next step is we need to square the deviation. Nothing but x minus x bar whole square. X minus x bar whole square. So here minus 3 into minus 3 plus minus into minus plus 3 into 3 9. Then 0 into 0 0. 2 into 2 4. 1 into 1 1. Then so after getting these values, what we have to do? The summation of x minus x bar whole square. Nothing but we need to add this square deviation values. Square deviation values. That is called formula. Sorry, here. Yeah, sum of x minus x bar square is equal to 11. See how we can 11 comes 9, not 2. Here, see it is a square value. So 9 plus 0, 9, 9 plus 4, 13, 13 plus 1, 14. You got 14. Okay. Then we can substitute these values in the equation or formula. See s is equal under root of summation of x minus x bar square. How much? 14. We got 14. And divide by n minus 1. What is n here? Number of observation. How many are there? 1, 2, 3, 4. Then 4 minus 1. The next step, standard deviation, the root of, as it is, we can take 14 and 4 minus 3, we will get 3. Then when you cancel it, standard 14 by 3, 14 by 3, a calculator is visible for you. Then 14 divided by 3, you will get 4 point. Sorry. say 14 divided by 3, how much you are going to get? 4.6. 4.6. So you can write it standard deviation under root of 4.6. When you cancel the root, how much you are going to get? So simple, you can write in you can take the calculator in mobile. Say you can enter into root value, then you can enter the value 4.66. 4.66. So then only you will get 2.16. When you cancel the root value, you are going to get 2.16. Is it clear? Hello?
Yes, sir.
Yes, sir.
Here I am unable to find out the root value, symbol here in the calculator. So simple, you can take your mobile and you can open the calculator. So there is some root value, root of x. So first you can enter you can click that root value, then you can enter value 4.666. Then you are going to get 2.16. The standard deviation is 2.16. So what is the meaning of 2.616 here in statistical orientation and in the research orientation? When you calculate standard deviation, you need to conclude on the basis of standard deviation. So here, in basically the standard deviation, I think, but so the standard deviation, how much is deviating from the mean value? Nothing but and each observation, how much is deviating from the mean value? What is the mean value here? 5. So here, what is the difference between 5? Generally, when we compare difference between x value and average value, that is called how much is deviating from the mean value. That is called 2 and 3. Sorry, 2, 5. So generally we can get 3. So that is not a observed difference. So here the observed difference is nothing but 2.16. And average, each observation is deviating from the mean value. That is 2.16. 2.16. Am I clear?
Yes, sir.
So if you understood only, then I will go to the next. Shall I go next one?
Yes, sir.
Thank you. Then see next one.